Hi everybody, in this video we're going to discuss section 1 of chapter 1 and we'll be talking about linear equations in this particular video. Specifically, we are going to go over some terminology so that we have all the same nomenclature or that we know what we mean when we say certain things. Then we're going to talk about how to solve linear equations, how to identify 3 different types of linear equations, identities, conditional equations, and contradictions. And finally, we will use these to solve what we call literal equations. And these are basically formulas with a number of variables. We will have one variable of interest, which we're going to solve for, and then there'll be some other letters and numbers, and those letters will be known as parameters. Okay, so let's get going. And the first question is, well, what the heck is an equation? Well, an equation is a statement. It is a mathematical statement. And it is a mathematical statement that contains an equal sign, which basically means it's a statement where both expressions are equal. So this right here is a statement. And this statement says that x plus 2 is equal to 9 plus x. Now even though this is a statement, and if you look at this, you will realize that this is false. There is no way that x plus 2 can be equal to 9 plus x for any value of x. As a consequence, even though this is a statement, this statement happens to be false. Now, if you look at this statement right here, this is also a statement. It says 11x is equal to 5x plus 6x. And this statement happens to be true for every single x that you want to put in there, where x can be a real number. And finally, we have this statement here, which says that x squared minus 4 is equal to 0. And it turns out that this statement is true when x is either equal to 2 or when x is equal to minus 2. If x is equal to 0, it is false. If x is equal to 1, it is false. So basically, the truth for this particular statement is conditioned upon the value of x. So what does it mean when we solve an equation? Well, basically, it means that we are going to find all the numbers on the real line that will make these statements true. For some cases, there is no number that can make that statement true. We call that a contraction. For other equations, there may be exactly one number that makes that statement true, such as a linear equation. In some cases, there could be 2 or more numbers which would make that statement true, such as in this equation, which is called a quadratic equation, there are 2 numbers that make the statement true, so there are 2 solutions. And of course, then there are some equations where every single number on the real line can make the statement true. And those numbers that can make that statement true, that can make that particular statement true, we call them solutions. And furthermore, the collection or set of those numbers which makes those statements true, which causes that statement to be true, whatever statement that happens to be, is what we call a solution set. So for example here, the solution set for x plus 2 equals 9 plus x is the empty set because nothing can make that statement true. The solution set for x plus 1 equals 10 is the set 9. The solution set for x squared minus 4 is equal to 0 are the 2 numbers negative 2 and 2. And the solution set for 11 equals 5x plus 6x is the entire real line. One of the things that you will have to get used to in this particular course is writing your answers or writing your solutions in terms of solution sets. In MML, whenever you're asked to solve an equation, it will ask you to provide it with its solution set, which is basically a bracket with all the possible solutions with a closed bracket. So it will either look like this or it will look like this. Now, also, if you have 2 equations that have the exact same solution set, you would say that those equations are equivalent. For example, x plus 1 equals 10 and 2x plus 2 equals 20 are equivalent equations. Why? Because they have the exact same solution set, happens to be 9. And the same argument you can apply the same argument with these 2 equations down here. Okay, now in solving linear equations or solving equations of any form, we tend to use 2 properties of equality. The first property of equality is the addition property of equality. And what does it say? Well, it says that if A equals B, then a plus c will always be equal to b plus c. And these two equations will always be equivalent. They will have the exact same solution set, whatever that happens to be. Similarly, we also have the multiplication property of equality. And that says the exact same thing, except we're multiplying instead of adding. So if a equals b, then a times c will be equal to b times c for any c with the exception of c equals 0. Well, actually, also would include for c equals 0, but it tends to break down in that particular case. And what does this tell you? Well, that's basically tells you if you want to manipulate equations or find the equivalent equations, the way you do that is by doing the exact same thing on both sides. So what you do on one side of the equation, you have to do on the other side of the equation. Okay, now, any equation that can be reduced to this particular form, some number, we're going to call it a times x, plus some other number b equal to 0, is what we would call a linear equation. Matter of fact, this is a linear equation in one variable in what we call standard form. Furthermore, I want you to notice that a linear equation is what we call a first-degree equation. Now, how do you determine the degree of an equation? Well, the degree is the largest variable exponent in the given equation. And notice here we have 5x plus 4 is equal to 2. Well, the x by itself kind of implies an x to the first power. And so since this is the largest exponent, this is a first degree equation. Similarly, over here, we have an exponent of 3, an exponent of 2, and an exponent and an implied exponent of 1. Since the largest exponent here is 3, this is a third degree equation. And similarly here, the largest exponent happens to be 7. So this is a 7th degree equation. And this brings us to our very first example. It's a real challenge, and here it is. Which equation here is not a linear equation? That's basically asking which equation here is not an equation of degree 1. Well, clearly A, C, and D have no exponents by their x, so these are all of degree 1. However, this one has a term with an exponent that is with an exponent of 2, which is greater than 1. So this right here is not a linear equation. It actually happens to be a quadratic equation. Oh, and there it is. Okay, now, how do we solve linear equations? Well, we solve linear equations by finding x. Well, that's beautiful. How do you find x? We find it by isolating the variable on one side of the equality. So we want to find an equivalent equation which has x on one side and all the other stuff, for lack of a better term, on the other side. Well, that's beautiful. Well, how do we do that? Well, it turns out that we have a tool chest that we can use. One is what we call the distributive property, and you guys have, hopefully have seen that before. That is basically says that A times the quantity B plus C is equal to the product of A and B plus the product of A and C. An example that's right down here. And we use the distributive property to get rid of grouping symbols. The other property the other tool that we're going to use is the addition property of equality. We use this to get all the terms that might have a variable in it on one side of the equation and all the other terms on the other side of the equation. And you can see an example of the addition property right here. Here we have x minus 6 is equal to 9. Now if I went and added 6 to both sides of the equation, that maintains the equality. We have an equivalent equation. And finally here the 6's will cancel. These sum to 15, and we will have x is equal to 15. Okay, our third tool is the multiplication property of equality. And how would we use this? Well, basically, we will use this to get rid. Once we have all the terms with the variable on one side and all the other terms on the other side, we will use the multiplication property to get rid of the coefficient. So here we have a coefficient x divided by 5 is equal to 20. If we use the multiplication property, namely multiply both sides by 5, then these will cancel. We'll have 20 times 5, and we will have x is equal to 100. And then finally, we will simplify. And how can we simplify? Well, basic simplification, that involves combining like terms. And what we're going to do is we're going to find all the like terms. And what is a like term? A like term are terms that have the exact same variable and the exact same exponent. So 4x squared and 7x squared are like terms, and they sum to 11x squared. 2x and 5x are like terms, and they sum to 7. And then, of course, since these have no variables, 11 and 1 sum to 12. So we will use these 4 tools to actually solve linear equations. Great, so let's go ahead and do that. Here we want to solve this monstrosity right here. 2x plus 4 over 3 plus 1/2 x is equal to 1/4 x minus 7/3. And what is our goal once again? It is to isolate x. And how can we do that? Well, once again, we are going to use multiplication, addition, simplification, and the distributive property to do these things. Now, the first thing that we might want to do in this particular case is to get rid of these fractions, because we don't like fractions. So the sooner we can get rid of them, the better. And the way that we can do that is by multiplying both sides of the equation by the least common multiple of all the denominators. In that particular case, the least common multiple is going to be 12. So we will have 12 times the quantity 2x plus 4 divided by 3 plus 1/2 x, and that's going to be equal to 12. Notice how I do the exact same thing on both sides. Times the quantity 1/4 x minus 7/3. Okay, now I'm going to go ahead and use the distributive property. 12 times 2x plus 4 over 3. Well, basically 12 divides 3, we will have 4, and that will give us 4 times the quantity 2x plus 4. And then 12 times 1/2 x, well, that's 12 divided by 2, which will give me 6 times x. And that'll be equal to, now using the distributive property here, 12 times 1/4 x. Well, 12 divided by 4 is 3, so that will be 3x. And then 12 divided by 3 is 4, so that'll give me 4 times 7. All right, now I have some more distributing. I can use the distributive property again over here, and that will give me 8x plus 16 plus 6x is equal to 3x minus 4 times 7 is 28. Now I can combine like terms, and if I do, I will have 14x, let me do this over here, 14x plus 16 is equal to 3x minus 28. Now I can use the addition property of equality to get all the terms with an x over here and all the other terms with an x without an x over here. So I can bring this term over here by subtracting 3x from both sides. So let me do that. Minus 3x here, minus 3x here. And then I can bring the 16 over here by subtracting 16 from both sides. Minus 16 here, minus 16 here. Now, when I add all this vertically, these cancel, which is what I'm looking for. These cancel, and then I will have 14 minus 3, which is 11x. And that's going to be equal to negative 28 minus 16, which is negative 44. Now I can use the multiplication property of equality and multiply everything by 1 over 11th, which is just like dividing by 11. And if I do these cancel, I'm left with an x. And then I have x is equal to negative 44 divided by 11, or minus 4. Now, does this work? If it does work, then I should be able to substitute x back in here and verify that the equality actually holds. Okay, let's go ahead and do that. And if I do, I will have 2 times negative 4, which is negative 8, plus 4 will be negative 4. So I'm going to have negative 4/3 minus 2. And that is going to be equal to, well, that's going to be minus 1. Negative 4 divided by 4 minus 7/3. Okay, well, over here I can write the 2/3 as 6/3, so it's be negative 4/3 minus 6 over 3. I'm writing over myself. I apologize about that. And over here, I can write this as negative 3 over 3 minus 7 over 3. Well, negative 3 over 3 minus 7 over 3 is going to be negative 10/3. What about over here? Let me rewrite that again. I'm going to have negative 4/3 minus 6/3. That's also equal to negative 10/3. So it works out like a champ. Okay, And this brings us to identities, conditional equations, and contractions. And we kind of already discussed them when we talked about these types, when we went over these equations, not these equations, but these equations here. Okay? But we're going to talk about it more explicitly on this particular slide. There we go. Okay, well, an identity is an equation that is true for every single number on the real line. And here's an example of what's an identity, of an identity. If I actually expanded this, I would have the exact same thing on both sides of the equation, so it would be true for any value of x. A conditional equation is like the equation that we just solved. It is only true for some numbers and not true for other numbers. For example, this equation right here is only true if x is equal to 2. If x is not 2, then this equation is, or this statement is false. And then finally, a contradiction is an equation that has no solution whatsoever, such as this one. This one, where the 4x's will cancel and then reduces to -8 is equal to -12, which is basically, which is nonsense. And as a consequence, there's no value of x that can make that solution true. So, how do you identify each type of linear equation? Well, first thing you want to do is you want to solve for the variable of interest, which is typically x. Then, if the solution leads to a true statement, such as 0 is equal to 0, or something which is kind of obvious, which obviously will reduce to 0 is equal to 0, or basically if it leads to any true statement, then it is identity. And the solution set will be either all real numbers or script R. Secondly, if the solution set leads to a statement such as x equals 2, like in the first case, well, then the equation is conditional, and the equation solution set will consist of a single element. And remember, we're talking linear equations. So if you have a conditional linear equation, there is only one solution. And then finally, if the solution set leads to something which is completely ridiculous, then it's a contradiction, and the solution set is what we call the empty set. Okay, so let's do a couple of problems here. Here we have an equation, and we want to determine whether or not it is an identity, a conditional equation, or a contraction. So what do? We go ahead and solve for x. Now to do that, we got to do a little simple. We have to use our distributive property first, so let's go ahead and do that. And if we do, we will have -2x, -2 times +4 is -8, plus 3x, and that's going to be equal to x minus 8. Now notice we have two like terms here, -2x and 3x, and we can combine those, and if we do, we'll have x minus 8 is equal to x minus 8. And you really don't need to go any further. This is a statement that will be true for all x. So this right here is an identity. Okay, well, let's try one more equation. And here it is. Here we have 3 times the quantity 3x minus 1 is equal to 9x plus 7. And we want to know if this equation, this statement, is an identity, a conditional equation, or a contradiction. So let's go ahead and check this sucker out. Okay, first we need to distribute. So let's go ahead and do that. 3 times 3x is 9x. 3 times -1 is -3. And that's going to be equal to 9x plus 7. Now we can attempt to move all the terms with the x's over here, so let's go ahead and do that. I can subtract 9x from both sides, and I could play with this, but let's not bother. And if once I do this, these cancel, I have -3 is equal to 7. This is, well, you could say that the technical term would be false. There's no way that -3 can be equal to 7. As a consequence, this is a contradiction. And of course, example 2, that would be a conditional equation. Okay, now we want to talk about literal equations and solving specific equations for a specific value. But before we do that, let's talk about this particular formula. Notice that in terms of t, this is a linear equation. In terms of r, it's a linear equation. In terms of p, it is a linear equation. So this is what we call a literal equation. And actually, this is the simple interest formula. This is the formula that gives you the amount of money you will have to pay off. Okay, we call it A, or the future value. If you borrowed P dollars now, and you paid it off in 10 years, after being charged a simple interest rate of R as a decimal. So we have A as a future value, P is the amount that you borrowed. This right here, this quantity right here is the interest. This is your annual interest rate, which is expressed as a decimal, and T is always your duration in years. And one of the things you might be asked is to solve this equation for P. And if you do that, you're basically answering this question. Suppose that you know that you can pay back $8 in 10 years. How much can you borrow now if the lender charges an annual simple interest rate of R? And what we want to do here is we want to isolate P. So how can we do that? Well, the first thing we can do is we can use, to isolate P, we can use the distributive property in reverse. We call that factoring. We're going to get a whole bunch of that. I think it's in chapter 3. Yeah, chapter 3. Okay, so if this is the case, we can actually rewrite this as P times the quantity 1 plus RT. This is kind of like using distributive property in reverse. So then we will have A is equal to P times 1 plus RT. Basically, we have P times a number. This is our coefficient. So how do we get rid of coefficients? We use the multiplication property of equality. So I'm going to multiply everything, both sides of the equation, by 1 over 1 plus RT, which is basically dividing everything by 1 plus RT. So I'm going to divide this side by 1 plus RT and this side by 1 plus RT. And if I do, well, these cancel, and then I will have P is equal to A divided by 1 plus RT. And you'll have to do these for a couple of different type of problems. For example, you might find a problem where the area is equal to the base times height of a rectangle, and they might want to find the height or whatever. And of course, there's always the classic Fahrenheit and degrees conversion, or the Fahrenheit and Celsius conversion problem that you will encounter in this homework. Okay, the last thing that you're going to see are a few examples. And some of them will be simple interest examples, such as this one right here. Now here we have a guy named Miguel. He's borrowing $400 from his brother Julio to pay for books and tuition. And he agreed to pay Julio 6 months with an annual simple interest rate of 6.7%. And the first question is, how much interest did he pay? Well, the formula for that is right here, PRT. So the interest is going to be equal to PRT, where P is the amount that you borrowed, R is the interest rate as a decimal, not a percentage, and then T is the duration in years. Okay, so P is $400. Okay, R is 6.7%, which is equal to 0.067. To convert a percentage to a decimal, you always divide by 100. And then T is 6 months, but we can't use 6 months. We can only use years. Oh, and so I forgot the H there. So 6 months is actually equal to 1/2 of a year. Okay, so if we do all these substitutions, we are going to have that I is going to be equal to the principal, which is $400. The interest rate, which is 0.067 per year, times 1/2 of a year. And if you break out your calculator and punch in those numbers, you will find that the interest that he paid was $13.40. And then your next problem here is, how much will Miguel pay Julio at the end of 6 months? Well, let's come back to this equation up here again. Notice that how much Miguel's going to pay is going to be equal to how much you borrowed plus the interest. Okay, well, we've already computed that, so it's just basically this number, which is $13.40, plus the amount he borrowed, which is $400. So, oh, too far. So how much will he pay? Well, he's going to pay the future value, which is going to be equal to the principal plus the interest, or principal plus PRT, and of course we already computed PRT, we computed up there, so this reduces to $400 plus $13.40, and all this will be equal to $413.40. And that would be your answer for that particular example. And that covers everything that I wanted to discuss relative to this particular section. If you have any questions, please feel free to contact me. This is Bob Oil, signing off.